Okay, guys, here's a video I wanted to do about wind. And we're really moving right along here, and I know this is a lot of information. This is definitely one of the harder units of the course, but just stick with it. And again, if you are having a hard time with anything, you could ask questions. Also, go back and look at the videos again. You might want to look at a particular part of the video maybe even 2 or 3 times, to make sure you really have certain concepts down. So anyway, let's talk about wind. So we obviously all feel the wind, and we could define wind as a horizontal movement of air. Now, the primary reason that we have wind in the first place is uneven heating of Earth's surfaces. If the planet warmed up evenly all the time in all places, we wouldn't have wind. So there are many examples or reasons why we have uneven heating. For example, land always heats up faster than water. And I think that's a concept we've talked about before. Water has a high specific heat. It takes a very long time to heat up. Land heats up more quickly, especially dark-colored land, but all land heats up faster than water. We have differences in latitude, like the poles versus the equator. And I kind of just mentioned this a minute ago, but also the color of the land surfaces. For example, dark forest is going to actually heat up more than snow and ice. Wind distributes the heat energy and basically balances heat. It spreads the heat out from areas where there's high heat to areas where there's low heat. And if it weren't for continuously uneven, or let me rephrase that, constantly uneven heating, the temperatures would eventually balance out, is what I'm trying to say, I guess. But because the constant uneven heating, it never stops. The poles are always going to be cold, the equator is always going to be warm, dark forests are always going to be hotter than the snow and the ice, the land always heats up faster than the water. If it were a one-time thing, eventually things would balance out, and we wouldn't have warm or cold, it would all be the same. But because we're constantly unevenly heating surfaces, we are constantly creating wind, and the wind is constantly trying to balance things out, but we're constantly having uneven heating, so it's just kind of always going. So let's really get into wind. One of the first wind patterns we'll take a look at is what's called the sea breeze and the land breeze. So we'll start out with the sea breeze first. And in the case of a sea breeze, this has to do with the difference in heating between water and land. During the daytime, the water is cool. We go to the beach and we cool off. We go in the water, it feels good. On the land, it's warmer. So we have a temperature difference there. The land heats up faster, it's warmer. The water doesn't heat up as quickly, it stays relatively cool. And again, that's why we go to the beach in the summertime. We cool off. Because the air over the land is warmer, it's less dense, which means that it rises. The air is going to rise, and then as it cools, it's going to spread out. This is convection. We talked about convection a long time ago, especially back when we were talking about Earth's mantle and the way that magma or mantle material was moving and circulating in the outer core. Anyway, the hot air rises and spreads out in all directions, and it begins to cool. And eventually it's going to start to sink. It becomes more dense because it's getting cooler and it sinks. And eventually it's going to make its way back to the land. And this is what we refer to as a sea breeze. The wind is coming off of the ocean. And many of us have probably noticed that. You go to the beach in the summertime and, you often see people even flying kites, and you're always getting that nice cool breeze coming off of the ocean. And this is why. It's really because the land is heating up first. It gets warmer more quickly, the hot air rises, and then it moves outward in both directions. It cools, but then it hits this cool air of the ocean, and it brings in this nice cool breeze off the ocean, and we call that a sea breeze. It makes the ocean pleasant in the summertime especially. At night, though, and that's why there's this little moon here, we have what's called a land breeze. And if you spent a lot of time at the beach, you might have noticed this. But we have a reversal of the pattern. At nighttime, the land cools off rapidly. The ground gets cool fast. But because that water has that high specific heat, well, now the water is relatively warm. In reality, it's basically the same temperature as it was in the first picture, but now we would call it warm because the land has cooled off so much. The land cools down really quickly, loses a lot of heat. The water retains its heat. Remember, high specific heat, it heats up and cools down slowly. So the water is now relatively warm compared to the land. So now we have the opposite pattern occurring. We have air sinking now over the land. The air cools and sinks. And now the breeze is going out to sea. It's coming from the land, so we call it a land breeze. And then it hits that warm water and it will begin to rise over the ocean. So those are sea breezes and those are land breezes. Okay, maybe I'll stop here and we'll divide this video up into two segments, but that's one key idea. Sea breeze versus land breeze.